Good morning. In the previous video that we discussed the methods in solving quadratic equations. For today's lesson, we will discuss two methods that are related. So we have lesson 3.2 will be solution by A, extracting roots using the square root property, and solution by using the definition of absolute value. Okay, so what do we do when we use extracting roots or using the definition of absolute value? I will discuss these two methods simultaneously because they are very much similar with each other. For both methods, we want to have this quadratic equation here be written in the form triangle squared is equal to p. So this will be our starting point for both methods. So I will split the screen here so that I will present the solution through extracting roots on the first column and using the definition of absolute value on the second column. We know that when we use extracting roots method, we are going to use the square root property. If triangle squared is equal to p, then triangle equals plus or minus the square root of p. We just extracted the square root of this triangle, which will give us triangle equals plus or minus square root of p. For example, suppose we have 2x squared minus 18 equals 0. According to what we have said earlier, we want to express this quadratic equation into the form triangle squared equals p. So first things first, we are going to have 2x squared equals 18. But then again, we said that we want to have the coefficient of the squared term there be equal to 1. In this case, we want to transform 2 so that this equation will now have this equal to 1. We can do that by MPE by the multiplicative inverse of 2, which gives us x squared equals 9. From this equation now, we are now ready to apply this square root property. So, if x squared equals 9, then x equals plus or minus square root of 9. Instead of me having if and then statement, I can just say x squared equals 9 implies that x equals plus or minus square root of 9. Or this gives me plus or minus 3. Hence, the solution to this equation is 3 or negative 3. Okay, this is using extracting roots. We rewrite this equation in the form triangle squared equals p so that we can use this square root property. Let's have this same problem be solved using the definition of absolute value. Practically, we want to have this equation again transformed into this format. Okay? So, after we have transformed this to this format, we are going to introduce the absolute value definition. Recall in our previous lecture that we just need to introduce this square root symbol and rewrite this square root of triangle squared into its absolute value form, which is absolute value of triangle is equal to square root of p. Notice that when I introduced the square root symbol to both sides of the equation, I did not introduce plus or minus. Here on the right hand side, I just wrote it as square root of p. And from this form, we can now apply this theorem. Absolute value of x equals k implies x equals plus or minus k. Here, I am not requiring that k is greater or equal to 0 or p here is greater or equal to 0 to allow me to consider non-real roots. Therefore, if we solve this problem now, let's have an example here. If we solve 2x squared minus 18 equals 0 using the absolute value definition, I will follow what I did here by expressing the given equation into the form triangle squared equals p. So I get here by APE, I will get 2x squared equals 18, and by MPE, I will get x squared equals 9. If I am at this point already, I will introduce the square root symbol to both sides of the equation. This one now differentiates using the definition of absolute value and using the square root property. So having introduced the square root symbol, I can now rewrite this as absolute value of x. This is actually my goal, to be able to write that expression as absolute value. And square root of 9 is 3. From this theorem, I can now say absolute value of x equals 3 implies x equals plus or minus 3. Therefore, the solution set for this equation is 3 minus 3, which is the same as what we have there. Suppose we have this quadratic equation. We know that this is quadratic by this exponent here. We have here an x squared if we are going to expand this factor here. But if we want to solve this quadratic equation using extracting roots or using the definition of absolute value, then we need to have the form triangle squared equals p, something like that. Which means I am going to rewrite this equation by addition property. We will have x minus 3 squared equals 18. But we said that this constant here has to be equal to 1. So by multiplication property, I will now have x minus 3 squared equals 9. From this form of the quadratic equation, I can now apply extracting roots or using the square root property. And on this side, we'll be using the definition of absolute value. So, if we are already here, x minus 3 squared equals 9, I will just put an arrow here. So, the square root property tells us that if we have here a squared quantity equals 9, I can take the square root by just saying x minus 3 equals plus or minus square root of 9. Actually, I got the square root of this expression here. And that resulted to me writing this one. So I will get now here x equals 3 plus or minus, what is square root of 9? That's a 3. From this equation, the first root will be 3 plus 3. That will be a 6. The second root will be 3 minus 3. That will be a 0. So this will be your solution set. This will be the two values that will satisfy this original equation. For example, when x is 6, this will be 6 minus 3 is 3. 3 squared is 9 times 2 is 18. 18 minus 18 is 0. So that's correct. What about 0? When x is 0 here, we have a negative 3. And then we have a negative 3 squared will be 9 times 2, 18. Minus 18, that's still the same as 0. Okay, solving this same equation, same solution, same steps here. And then when we reach this portion and we want to apply the definition of absolute value, the only thing that you will have to do is introduce the square root symbol for us to be able to write this in its absolute value form. If you do it on the left hand side, you also have to do it on the right hand side. Now, we are ready to write this as absolute value of x minus 3 equals square root of 9 is equal to 3. Then, from here, I can use the absolute value theorem that we have, which means that when we remove this absolute value symbol, we have to introduce plus or minus 3 on the other side. And solving for x here, we get 3 plus or minus 3. And the solution will be 3 plus 3 is 6. 3 minus 3 is 0 as we had before. Let's have this last example. Suppose we have x squared plus 10x plus 25 equals 16. Our object here is to write this equation in the form triangle squared equals p. Recognize that x squared plus 10x plus 25 can be written as a square of a binomial because that's actually a perfect square trinomial. This is a perfect square trinomial. Equals 16 here. Now, this equation we obtained is of this form already. So, you may try using extracting roots or using the definition of absolute value. Again, I'm going to split the screen so that if I use extracting roots or the square root property, I am ready to use the square root property here by just writing this arrow here, and then this one implies that x plus 5 equals plus or minus square root of 16, or x plus 5 equals plus or minus 4. Solving for x here, we get x equals negative 5 plus or minus 4. And our solution set will be negative 5 plus 4 will be negative 1. Negative 5 and minus 4 is negative 9. Remember this form? Don't forget it. Once you have arrived at this form, then you can use the square root property. Like we had. If x squared equals p, then x equals plus or minus square root of p. What we did here is, I wrote it in a different manner. I have here x squared equals p. Then this implies that x equals plus or minus square root of p. So I want to have this format instead of saying if quantity x plus 5 squared equals 16, then this one. I can just say x squared equals p implies that x equals plus or minus square root of p. On the other hand, if we use here the definition of absolute value, we have the same format. We want to have this given equation transformed into this form. Now we already have this. So we get the coefficient of this expression here now is equal to 1. So I can now introduce the definition of absolute value by introducing square root to both sides. Remember, I just introduced this square root symbol without writing plus or minus there. My concern is to rewrite this in its absolute value form, which is actually x plus 5, and I will simplify this and it becomes a 4. If you are already here, our theorem now works. I am writing that theorem for the last time here. If I have absolute value of triangle equals k, then triangle equals plus or minus k. Applying it here, I have absolute value of x plus 5 equals 4 gives me x plus 5 equals plus or minus 4. Solving for x, I get negative 5 plus or minus 4. So my solution will now be minus 5 plus 4 is negative 1 and minus 5 minus 4 is negative 9, which gives us to the same solution there. Thank you very much and have a good day.